The last video introduced the remaining properties of logarithms that we need. And to now practice all the properties of logarithms, we are going to be doing two different things. We're going to be taking the logarithm expression and expanding it, and then also condensing it. So this video is going to focus on the expanding. Next video is going to look at condensing. And so when we say expanding is we want to take the expression and write it in an equivalent form so that it appears as a sum or difference of multiple logarithms. Okay, and so to do this, every step that I take, I'm going to try and do the recommended steps here. I'm going to first try to use the power law. Okay, so at every step, I'm going to say, okay, is there some way I can use the power law? Can I bring an exponent down front? Can I put an exponent that's in front up? Okay, so I have to be able to go both ways with the power law. Okay, similar thing what will happen with the quotient of difference and practice sum, but I'm going to try the quotient of difference law second, and then finally end with trying to use the practice sum law. Okay, so let's see these in action. First one, log base 2 of 2x to the fourth. Okay, so first I'm going to go through and say, is there a power? Well, yes, there is a power, right? But I need that power to be on everything. Is it on everything? No. So I can't use number 1. Okay, is there a quotient or a difference appearing? Is there subtraction or division? Nope, can't use that. So I'm going to actually start with the product of sum. Okay, is there a product? Yep, there sure is between the 2 and the x to the fourth. So I'm going to use that and say this is log base 2 of the first member of that product plus log base 2 of x to the fourth. Okay, and now guess what? I have to restart. Okay, so is there power? Actually, yeah, there is a power. Okay, so I'm going to start with power law. I'm going to bring the 4 out in front. So this is going to be log base 2 of 2 plus 4 log base 2 of x. Okay, all right, and now I restart. Every time you do a step, you have to restart. Okay, is there a power appearing? No. Is there a quotient or difference appearing? Division, subtraction, no. Is there product to sum? Or is there product and sum? Well, there isn't. There's some, but I don't want to bring that to a product because that's not going to expand it. It's going to condense it. And there's no other product, so I'm virtually done. The only thing that I can do is simplify this first one, which again, log base b of b is equal to 1. So I can just simplify that to 1 plus 4 log base 2 of x. And please, for the love of God, do not, no, this is wrong. Do not say that this is 5, right? PEMDAS supersedes all, right? So we'd have to do the multiplication here before we do the addition. So don't do that, okay? That's a bad, okay? Now, moving on. Next one, natural log of, oh, this hot mess. Okay, so first thing is, I don't like square roots, but I do like fractional exponents. So I'm going to write this as natural log of 32 parentheses x plus y all over e. And then this inside here would be to the power of 1/2. Okay. That way I can see the square root as a power. And then I'm going to begin with this recommended process. Do I have a power? Yep, I actually do. I have the 1/2. So I'm going to bring that out in front. 1/2 natural log of 32 parentheses x plus y all over e. And I'm going to omit the square brackets just because I've taken care of the exponent. Okay. So now I restart. Is there a power? No. Is there a quotient to a difference? Actually, there is, right? So I'm going to do the quotient. There's division here. So this is going to be 1/2. And now this expression splits into two things. It splits into natural log of the numerator, 32x plus y, minus natural log of e. Okay, and so that 1/2 would have to be applied to each term, which is why I put it in brackets. Okay, I'll distribute the 1/2 eventually, but not right now. Okay, so then next. Okay, so next I see, okay, let's just go through the process. Okay, is there a power? Nope. Is there any more quotients that need to go to a difference? No. Is there a product? Actually, there is. There is a product between 32 and the x plus y. So I'm going to take this term and split it into two terms. 1/2, and then this would split into natural log of the first term, natural log of 32, plus natural log of the second term, and then minus natural log of e. Okay, and this is nearly done. If I wanted to simplify, which I should if I can do 1/2 natural log of 32. So distribute the 1/2 to each term. 1/2 natural log x plus y. And then this whole thing, natural log is log base e, and then we have of e, so this is log base e of e, and that would just simplify to 1. So then I'd distribute a 1 times 1/2, and I'd just be subtracting a 1/2. Okay, just to add a little bit of clarity, there you go. Okay, and that would be fully simplified. Again, if you felt super motivated, and this is for individuals who are super motivated, 32 is 2 to the 5th. So you could write this as, say, 5/2 natural log of 2 plus whatever's left over there. But again, natural log of 32 is just fine. All right. So point being with all this, we want to get practice with our new exponent or our new logarithm properties, right? The power law, quotient difference, practice sum. One way we do that is by expanding, taking a compact expression and writing it in terms of multiple logarithms, okay? And we follow the process of trying to use the power law first, then quotient difference, and then practice sum, all right? And the next video, we're gonna go the other way. So we're gonna take a big, long expression like what we developed at the end here and work backwards, try and write it as a single logarithm. So more on that in the next video.